We are about to do oogenesis. So oogenesis speak to the production of the female gamete. Again, it can be viewed as a special type of meiosis because it's meiosis that gives rise to the production of haploid cells. So we look at the site of oogenesis, which is in the ovary, where you have the production of the female gametes, starting off with the germinal epithelial cells, similar to that of spermatogenesis, where we have that maturation of the germ cell into that of a oogonium. In plural form, we said oogonia, and that's a diploid cell that will undergo further maturation to become that of primary oocyte. The primary oocyte is also that of a diploid cell, and it will undergo meiosis 1, which is the first meiotic division. So therefore, the primary oocyte will be going through prophase 1, metaphase 1, anaphase 1, telophase 1. And at the end of the first meiotic division, we end up with two cells, and these two haploid cells. One will be that of a polar body, and one will be that of a secondary oocyte. Now, how is it that we differentiate between the polar body and the secondary oocyte at the end of the first meiotic division? The secondary oocyte is normally bigger, so we have, if you're drawing, you ensure that you represent it that way, unlike what we're seeing here on screen, that the secondary oocyte is normally bigger than the polar body. Now, we are going to move into the second meiotic division with these two cells. So remember, we have one secondary oocyte and one polar body. So when we move into the second meiotic division, that polar body that we are carrying over from the first meiotic division will divide to give us two polar bodies. Clear on that? And then the secondary oocyte will divide to give us two cells. One will be a polar body and the other will be a secondary oocyte. So at the end of oogenesis, we would end up with that of three polar bodies and one secondary oocyte, which will form that of the ovum. So when you look at this form of meiosis or meiotic division, we would realize that the the productivity of the process is lower than that of spermatogenesis, because here, though we may have four haploid cells at the end, the three polar bodies have no reproductive function, so they will degenerate, and only the ovum will be able to participate in fertilization. So it is the secondary oocyte, actually, that is fertilized. We refer to it as the ovum, but it is actually the secondary oocyte that is fertilized by that of the sperm cell. So just for clarification, we start off with that of the germinal epithelial cell, which will mature to give that of the spermatogonium, singular, spermatogonia, plural. Further maturation of the spermatogonium or spermatogonia will give rise to that of primary oocytes, and these are all diploid cells. If you notice 2n, the diploid number. And then we have the first meiotic division. We're looking at the first division of meiosis. So we're taking that whole diploid primary oocyte through prophase 1, metaphase 1, anaphase 1, telophase 1. And at the end, we end up with two cells. And one will be that of a polar body. The other will be that of a secondary oocyte. Now, these two cells, a polar body and the secondary oocyte, will be taken into the second division. And the polar body will give rise to two polar bodies, having completed the second meiotic division. And the secondary oocyte will divide to give us another polar body and that of a secondary oocyte. And then the secondary oocyte will mature into that of the ovum, or as I said earlier, it is the secondary oocyte that actually get fertilized or get released during the process of ovulation. All right. So I think that is it. I won't keep you on all through. What I will do is to continue recording some videos and add to YouTube, because it makes no sense. You can consult me through WhatsApp, and persons have been doing that. So I'll just do them in small fragments and label them accordingly, that you can digest them in the amount that they are presented in. All right? Clear enough?
Okay, sir. Yes, sir. Sir, I have one question.
Yes.
Concepts of oogenesis. When you get the secondary oocyte, will it divide by mitosis to give you like the synergids and the antipodals and the polar nuclei?
You're talking about reproduction in angiosperm, right?
Oh.
All right. Remember, we're looking at human reproduction. So when you talk about the synergies,
yes.
Now you're talking about gametogenesis in plants. All right. So
for human, it just stopped there.
Yes. So just look at oogenesis and spermatogenesis by itself, human reproduction. So yes, but that will speak more too. So I'll be doing a video on that shortly. All right.
Yes. Sir.
All right. Good. All right. We'll catch up. So we'll end here. Catch up. I'll cut those and upload them, and continue uploading. All right.
Yes, sir.
All the best.
Thank you.
All right then, Sean.